Hello everyone. So today we have the third lecture, that is lecture 3 of our this particular series, that is basics of trigonometry. So yesterday we saw what are amplitude, period, vertical shift and a phase in a wave form. So let us continue it and study what is the phase difference. So let me just define phase difference. Phase difference is defined as the difference in phase angles of two wave forms where one waveform may lead or lag the other waveform. So this is our definition of phase difference. So this was the diagram we saw yesterday, right? The basic waveform we took. Just let me take it again. Right. So here, what did we saw? Phase. So phase we saw there are different positions of the wave at different angles, right? So these are the different angles which we had in a sine wave, the mean angles, right? Though we have different angles between 0 to pi by 2 also, pi by 2 to pi also, right? So these all are at certain different angles. Our wave is making certain phases, that is phase angle, right? So now let me take another wave, right? So just let me mark them again. I'll just mark it here, right? So let us mark this pi by 2, this as pi, this as 3 pi by 2, right? And this is the okay, this as 2 pi, and here is our total time, that is time period, right? So here is another wave, right? Let this be another wave which is following certain path like this, right? So here you can see that when this wave started, right? Let it be y2t, or simply we'll name it currently B, right? This was A, right? Let this wave be, initial wave be A, and this be B. So when a B wave started, right? B wave started, A wave had already moved certain distance, right? Or certain time, right? So it had already moved this much, right? So here we can see, right? This is that when B started moving, A already had moved this much, right? So we know these are the phases, right? There are certain phases, right? Here will be also a certain phase, right? So the difference, that is this difference, right? This would be a constant difference between these two waves, right? Because they are sinusoidal, right? So this will be a constant difference, right? So we can find same difference here. This also will denote with phi. We can find same difference here. This also we can define. That means that wave B is always ahead of wave A is always ahead of wave B with a phase difference of phi, right? So this is something you can understand by an example, right? So let us take an example. Suppose there is a person A, right, and person B, This is person A and this is person B, right? So let A move at a certain time, that is 12 p.m., right? And what does B does? B moves, right? B moves at certain time which is already ahead of B. A moves a certain time which is already ahead of B, right? Let it move at 11:55 p.m., right? So this particular difference would be our time difference, right? Time difference. So this will always be a consistent time difference since both these are moving with same velocity. Let this velocity be v. Fine. So here we can see that there will always be a lead of phi, that is phi angle between both these waves, right? So this is what is a phase difference, right? And let me consider another case where we take the same wave, right? So let this not wave move from, let this wave move from this point, right? So here, right? So this was something. So what can we see? We can see now our basic wave, right? That is the wave A, right? That is the wave A, right? It started when wave B, right? The wave B had already traversed this much path, right? So now the wave which was moving later is not moving later, but it is moving prior to the basic wave, right? So this means that there this wave, a basic wave, right? It will lag this particular wave which has already moved this much, right? So here we can see, let me move this. So here we can see, right? So this is the phase difference. Again, this we have phase difference with a lag. Fine. So this will also be a consistent phase difference, right? Because both the waves have a similar velocity, right? So this will be a consistent phase difference. Fine. So now how can we write our definition? How can we write our equation? That will be A sine omega t plus minus phi, right? Yeah, this is the complete phase, right, of our new wave, which may lead, right? Lead means positive sign, which may lag. Lag means negative sign, right? Similarly, if our person B didn't start from here, but it started from somewhere, say 11:50 p.m., right? So there will always be a lead of 5 minutes between B and A, and here it will be a lag, right, with reference to the person A, right? So this is what is the phase difference, right? So now we will understand what is the path difference. So our sixth term is path difference. So difference is defined as the difference between the distances or distance covered by the two waves, right, or waveforms from the source as seen by the observer, right? So before studying about the path difference, we all know what is wavelength, right? So let me just tell you, wavelength is the distance between the between two crests or troughs of the wave, right? What does this mean, right? This means that if, just a moment, if this was a basic diagram, right? Let me just copy it here. Right, so this was our diagram. So what will be the wavelength? That will simply be the distance between the two crests, right? This is the crest, this is the crest, right? This is the trough and this is the trough, right? So distance between this and this, right? This will be denoted by lambda. Fine. So this is our wavelength, right? Distance between the crests. So these are our crests of a wave, and the down curve is known as trough, right? Similarly, this is a crest, this is a trough, right? So you can see that this particular distance, right? The lambda. Here also the wave is transversing the same distance, right? So we will simply write this distance also as lambda. Fine. So what will be this distance in case of a sine wave? This will be lambda by 2. Right. So this why I'm talking about this in a distance manner, right? You are seeing that this is time. So here we need to introduce one more term in our basic equation, that is y t is equal to a sine omega t plus minus kx plus minus phi. Right. So this is nothing but the path difference, right? And this is a phase, right? So since here, right, the wave started from initial point, so this will be 0. Fine. So we can again write for sine wave sine omega t plus minus kx, right? So let me write it in yellow color. So this is our wave for sine. Right, so this is the sinusoidal wave for sine function. Right, so now what is path difference, right? So there is a very famous experiment, right, which is known as Young's slit experiment to observe or to understand what is path difference, right? So we know that light, right? What is a light? Light is a form of light is a form of, say, energy which travels in electromagnetic waves, right? So again, it is traveling in a wave, so we can consider it as simple wave for the time being, right? There are three very important terms related to the light phenomenon, right, or the optical phenomenon, that is interference, superposition, right? And also you need to understand what is wavefront. So what is interference? Interference is nothing but interaction of two light waves, right? which will produce a new wave of different intensity, right? So here intensity in case of light, right? If we consider the intensity as I, so this is nothing but the amplitude of a wave, right? So intensity is like we can understand the sharpness of a wave, a sharpness of light. Suppose we see, right? We just take a mirror, right? Suppose here these are some light rays coming from a faraway source. So these all will fall on this mirror with a different intensity, with a different sharpness. So this is basically what is happening due to the amplitude, right? So this is what is the interaction of light waves, which will produce a new wave of different intensity, right? So in case of waves, right, there is two different interference, that is constructive or destructive. Fine. Constructive interference and destructive interference, right? This is which will give rise to, which is due to the superposition of two waves. This means that in superposition, what is happening? Two waves, when interfere, or we can say simply interact, they may add, subtract, right, or have the same amplitude, right, which is the resultant amplitude of the, or we can write this way, that this is the, which is the amplitude of the resultant wave, right? So simply this is something where amplitudes are adding, subtracting, right? Or if they are of same, they of two different waveforms, they have same, they have no, I mean, they don't add up, right? So don't subtract. So they are also, they will move with the same amplitude, right? Then we need to understand what is a wavefront. So wavefront is simply, so we know that light travels, right? Light will travel in circular. How this is the different, right? So light will always travel like this. So it will always meet at this point. All the rays will meet at this point within this circle. So all rays of light, right? When they meet in this circle, they have same phase, right? So let us now understand how we can let us now understand what is the path difference from the Young slit experiment, right? So what exactly happened in the experiment, right? There is a vertical sheet, right? This is a vertical sheet, and another vertical sheet I take, right? So this is another vertical sheet. Here we have a slit in this vertical sheet, and there are, let me take it a little far away. So there are two slits in this vertical sheet, right? So in this experiment, what did this experimenter do? Here, let there be a source of light. Suppose sun, a torch, anything could be there, right? So this is, let us take it as sun. Some rays of light will come out, right? So they will travel like this. This would be our wavefront, right? So some rays will travel through here, right? So from this point, these rays will travel like this. Mm, this rays will travel like this, right? So some rays will fall on this slit. Some rays will fall on this slit, right? Again, they get distributed from these two slits. Let this be S0, this be S1, and this be S2, right? So again, the rays are falling, right? And again, these rays are falling from slit 2, right? So just in order to understand the phenomenon, what happened? We kept a reflector, right? Let this be the observer, or in case of light, it will be reflector, right? So when these rays of light fell on this particular reflector or mirror, right? What did the young what did he observe? There were some fringes, right? Some fringes. Fringes simply means some patches, right? Some fringes or patches of light, right? Which were some were dark, some were light, right? So this was the experiment conducted, right? So what did he saw? This particular fringes were due to the interference, right? And there were two kinds of fringes, dark or light. So I'll just explain what is this constructive and destructive interference, but let me just tell you what was the main discussion topic, that is path difference, right? So from here, some rays of light fell parallelly, right? They started from this point, right? So they traveled the same distance. Let this be x naught, right? While some rays traveled like this, and some rays from this slit, they it also traveled like this, right? So make it again. So it traveled like this, right? So they were observed here, right? Observer O is here. So what did he say? He saw that this particular S1, let this be point P, right? So he saw that the distance S1 from the distance traveled by S1, right? This was less than the distance traveled by the X2, right? So to just measure distance, what we can do, we will measure this X1, right? And equally, we will cut some line here, right? So this becomes an isosceles triangle, right? So here, this particular leftover distance would be our path difference, right? So we got exactly what is happening. This is del x represented by del x, and this will be x2 minus x1. So this will be our path difference. So this is how we can experimentally find out what is the path difference, right? So I hope you have got what is path difference. Now quickly we'll see what is constructive interference and destructive interference, right? So when what happens? This is a waveform, right? So it is traveling, and this is another waveform, right? Both are traveling, right? When there is no phase difference, right? There is no phase difference between the two. So these will be adding up, right? Their amplitudes will be adding up, right? So A plus B is the amplitude. Say A is the amplitude of A wave, B is the amplitude of B. So both will add up. So adding up will increase the amplitude, right? It will increase the amplitude. This means that intensity or the sharpness has increased. So there we will get a bright fringe, right? So this is constructive interference. Similarly, if one this is another, right? This so here we can see there is a difference in phase, right? When this was here, right, and this was here, so this wave had some say angle phi, which it obtained here, right? So which phase? Sorry, this phase it obtained here y phi one. This phase it obtained here phi two. So the difference is phi 2 minus phi 1. So their amplitudes will simply, because these are completely out of phase, how this is going like this and this is following an anti-path. So these are completely out of phase. So this will be subtracting. So there we will get a lesser amplitude, a wave with lesser amplitude, right? So here where this intensity I sharpness was less, we got a lighter fringe, right? So uh, I mean the which means that this is a dark patch, right, and this will be a bright patch, right? So this is what is the interference between these two waves is constructive, right? Constructive interference, and the interference between these two waves is destructive. Fine. So if we see our diagram again, right? So what is the part difference here? This was our total lambda, right? And then I have taken another waveform. This is another waveform, right? So it started from this point. So this is our this this particular distance will be our path difference, right? So this is, since the complete path is lambda, so this is lambda by 2, right? So this is our path difference between these two waves, right? Now we will see what is the relation between path difference and phase difference, right? Suppose we see that complete wavelength is lambda, right? And for this, what is the phase is just 2 pi, right? So when lambda length is traveled, suppose the phase is 2 pi, right? So if we have this, if we have a phase of theta, right? Sorry, a phi, then it is related to the, this would be del phi. It is related to the path difference like this. So this is the relation between phase difference and path difference, where 2 pi by lambda is our wave number, right? So, and its unit is meter 1, that is length inverse unit. So this is our, so this is the relation, and this was all about today, right? So we have seen the path difference and phase difference. How does both they we can obtain, right? And we saw the relationship between the path difference and phase difference. So let's wind up for today, and tomorrow we will be taking some numericals on whatever we did, right? So tomorrow let us do some numericals, and day after tomorrow we will be taking the our main course of trigonometry, that is diagrammatic representation of trigonometric functions in a unit circle, right? I know this is a lengthy taking process because these were the some fundamentals I wanted that you should understand before we start up with the trigonometry. So thank you for the day. Thank you. And please do like, subscribe, and share if you are enjoying my videos. So thank you for the day.